This lesson is about theoretical and experimental probability. Deshaun can choose 2 of his 4 t-shirts to take on a weekend trip. Alright, 2 of his 4 t-shirts. If the t-shirts are labeled A, B, C, and D, which choice represents the sample space S for the event? Now, the sample space is just a list of all of the possible outcomes. So 2 of his 4 t-shirts, so let's do all of the possibilities that involve shirt A first. Okay, so if we do all the possibilities that involve shirt A, let's see, just going to put a few A's down here. Don't know if I'm going to need that many. Okay, now looking at his remaining shirts, so he could do shirt A with shirt B, and shirt A and shirt C, and shirt A and shirt D. Okay, so those are all the possible ways if shirt A is one of the shirts. Okay, now how about possible ways if shirt B is one of the shirts? Okay, well, we already have one right there. Okay, so we could have shirt B with shirt A. We've already got that. But we could also have shirt B with shirt C, or shirt B with shirt D. Alright, so we've got those possibilities. Now let's focus our attention on shirt C. Well, we've already got shirt C and shirt A, shirt C and shirt B. That just leaves shirt C and shirt D. Alright, that was the only one that was left. Alright, now what about shirt D? Well, we already have listed all of the 3 possibilities for shirt D as well. Shirt D with shirt C, shirt D with shirt B, and shirt D with shirt A. So, these are all the possible ways of picking 2 of his 4 shirts. And you can see this list matches this sample space right here. So this is going to be the answer. Notice the reason why we're not going with the next option, they're listing options like A, B, and BA separately, where they're just changing the order. But if we're just talking about what shirts we're packing, saying AB and then saying BA, it's still the same 2 shirts. So it doesn't make sense to list AB and BA. It's still shirt A and shirt B. The order wouldn't matter in a situation like this. So that's why the last one is definitely not it. Alright, let's do the reveal and make sure that we were right. 4 runners, Fran, Gloria, Haley, and Imani, compete on a relay team. Haley is the first runner in the relay. The other runners can run in any order. What is the sample space showing the possible orders of the 3 runners, the other 3 runners? Okay, so we know that Haley is the first runner, so that leaves Fran, Gloria, and Imani. So again, the sample space is just going to be a list of all of the possible orders of these remaining 3 people. So let's start with Fran, okay, as the first person. Okay, so it could be Fran followed by Gloria and then Imani. Okay, or it could be Fran and then Imani and then Gloria. Okay, now let's do the ones if Gloria is first. Alright, well, I mean, you know, Haley is really first, but other than Haley, you know, so I guess I should say the ones where Gloria is second. But anyway, if we have Gloria, followed by Fran, and then Imani. Or we could have Gloria, and then Imani, and then Fran. So those are the ways if Gloria were out front. That leaves, let's look at the ways if Imani is the first of the three. All right, if Imani is the first of the three, then it could be Imani and then Fran and then Gloria. Or it could be Imani and then Gloria and then Fran. Okay, so this is the sample space for the remaining three runners in terms of the orders they could go. 1, 2, 3, 4, 5, 6 of these things. So I'm really just scanning down and I'm counting 1, 2, 3, 4, 5, 6. So it looks like it should be this one right here. All right, and if I had to look carefully and look for the letters, you know, yep, they're the same. Okay, let's check it out and make sure we were right. Yep, we're geniuses. April is randomly choosing 5 CDs to bring in her car from the following: 6 pop CDs, 8 rock CDs, 10 R&B CDs. What is the complement of April choosing 5 pop CDs? All right, complement just means not doing whatever it is that you're about to say. So looking at the event of April choosing 5 pop CDs, that's all 5 CDs that she's picking would be pop CDs. The complement of that would be, what if that didn't happen? In other words, she's picking 5 CDs and not all of them are pop. All right, that means at least one of them would be rock or R&B. Okay, so let's see the choices and see which one says the event would be not picking all 5 pop CDs. So choosing 5 CDs where none of them are pop. No, it doesn't have to be that extreme. All right, it could be 4 pop CDs and 1 not pop, and that would make it part of the complement. It just can't all be pop. They don't have to be none of them. Choosing 5 CDs where not all of them are pop. Boom, that sounds like it. All right, choosing 5 CDs where not all of them are pop. Choosing 5 CDs where at least one of them is pop. Nope, didn't have to be that. Choosing 5 CDs where all of them are pop. Well, that's the original statement, not the complement. So it should be the second one. What do you know? A cafeteria manager can choose from among 6 side dishes. All right, we have 6 side dishes for the lunch menu. Applesauce, broccoli, corn, dumplings, egg rolls, or French fries. Let's see. Oh, I see what they're doing here. A, B, C, D, E, or F. How nice. Okay. He uses a computer program to randomly select 3 dishes for Monday's lunch. What is the theoretical probability that applesauce and broccoli will both be offered on Monday? Okay, the theoretical probability is always the number of favorable outcomes divided by the total number of outcomes. Okay, and when I talk about this in my classes, I usually like to say target over total. All right, it's the number of target outcomes divided by the total number of outcomes. Target over total. All right, so in this case, the target outcomes are outcomes that involve broccoli and applesauce. The total number of outcomes, well, it would be the total number of outcomes. So we need to figure out how many outcomes would involve applesauce and broccoli, and what's the total number of outcomes. All right, let's start with the total number of outcomes. We have a total of 6 options, of which we are selecting 3 at random. All right. Now the order doesn't matter. We're just making groups of 3. So we're going to talk in terms of combinations as opposed to permutations. Okay. So there's a total of 6, of which we're making groups of 3. We're selecting 3. So it's a 6 choose 3 situation. So that is how we will calculate the total number of outcomes. We'll use our calculator for this. If I want to do 6 choose 3, then I type the 6 in first. I go to the probability menu. The second option is for combinations, and then I put the 3. So 6 choose 3. So that's 20. All right, so there are 20 total possibilities. All right, now we need to figure out how many of those 20 involve broccoli and applesauce. All right, I think we can rely on our common sense for this one. We're talking about selecting 3 dishes. If we already know that 2 of them are applesauce and broccoli, okay, let's see, what are the other possibilities? Okay, what are the possibilities for the other one? So applesauce, broccoli, applesauce, broccoli, applesauce, broccoli, applesauce, and broccoli. All right, there's only one open space for the third dish. So either it's going to be applesauce and broccoli and corn, or applesauce and broccoli and whatever D was, dumplings, or applesauce and broccoli and egg rolls, or applesauce and broccoli and French fries. All right, these are the 4 possible ways of having applesauce and broccoli with whatever the third thing would be. Okay, there are 4 options. So 4 of the 20 possibilities, 4 of the 20 total outcomes involve broccoli and applesauce. So that's 4 out of 20. Okay, so let's see, 4 out of 20. That's going to be, that reduces down to 1/5, or as a percent, that would be 20%. Okay, and now if you don't know that in your head the way I do, if you've got 1/5, you can figure out the percent by turning that into a decimal and then move that decimal point over twice. All right, so 0.2 becomes 20%, or you can multiply by 100. Either way. I said 100, but I didn't do 100. So if I do 0.2 times 100, all right, that's 20%. But you can just move the decimal point twice. Okay, so 20%, boom, there you go. A briefcase has a 3-digit lock code. Boom, boom, and boom. That does not include 0. No 0. All right, as soon as I see no 0, that tells me that there are 9 choices. Okay, for the numbers 1 through 9, there's no 0. Okay, so keep that in mind. Now, what is the probability that the lock code consists of all even digits if the same digit is not used more than once in the lock code? Okay, all even. All right, so we need So the probability is going to be the target number of outcomes divided by the total number of outcomes. All right, target over total. Let's start with the total number of outcomes. Okay, I don't know where that squiggly crazy line came from. The total number of outcomes, I like to use the fundamental counting principle for this type of problem because I know I have 9 choices for the first digit. All right, but since they're not using any more than once, that means for the second digit I will have 8 choices left. And for the third digit I will have 7 choices. So according to the fundamental counting principle, the total number of ways that this could happen is going to be 9 times 8 times 7. Okay, that's 504 possibilities. So that's the total number, is 504. Now, how many of those 504 possibilities involve all even digits? So the even digits are 2, 4, 6, and 8. Those are the only even digits. So there are 4 of them. Okay, so if I was going to have all even digits, again, I'm going to use the fundamental counting principle. For the first one, there are 4 possibilities. And for the second one, then there would be 3. And then that would leave 2 options for the third one. And according to the fundamental counting principle, the total number of ways this could happen will be 4 times 3 times 2. 4 times 3 is 12, times 2 is 24. Okay, so that would be 24 out of 504. So it would be the first option. And there you go. Okay, now we also could have looked at this as a permutations problem. So just very quickly, when we talked about the total number of possibilities of for this 3-digit code, again, there are 9 digits, and we are picking 3 of them. Since we're not repeating any, you could think of it as just selecting 3 of the 9. So the order matters, of course, because, for example, the code 231 would be a different code from 132. So the order does matter. So we're talking about permutations. So there's a total of 9, but of those 9, we are picking 3 for the code. So if I wanted to find the total number of codes you could make in this way, you could do 9 pick 3. Again, you do the 9 first, go to probability. Option number 1 is permutations, and then the 3. So this is a 9 pick 3, and you could get your 504 that way. All right. Similarly, if I wanted to talk about the target number of codes, the number of codes that have all even digits, well, instead of 9 choices, if I'm talking about even digits only, as we explained before, the even digits are 2, 4, 6, and 8. So if we're talking about evens, we have 8 choices. Okay, don't ask me what I was spelling with the COH there. Choices. Okay, so instead of 9 choices, wait, why am I saying 8? I really should just restart this whole video with that many mistakes in it. 4 choices. 2, 4, 6, and 8. All right, there are 4 choices if we're talking about even values. So of those 4 choices, we're picking 3. So you could think of this as a 4 pick 3 situation. All right, to figure out how many codes you could pick in that situation. So again, if I want to do 4 pick 3, I go 4, probability, first option, and then 3. All right, so that's how you could get your 24. All right, and the rest is the answer is the same. A random number generator is used to create a list of 150 single-digit numbers. Of those 150 numbers, 72 are odd and 78 are even. The number 9 was generated 15 times. To the nearest whole percent, what is the experimental probability of an odd number other than 9? An odd number other than 9. Okay, so the experimental probability is going to be the target number of outcomes in the experiment divided by the total number of outcomes in this experiment. The total number of outcomes, well, we're talking about 150 single-digit numbers, so it just tells you the total number of outcomes is 150. Now, the target is odd numbers other than 9. So we know that there are 72 odd numbers, okay, but we want the ones other than 9. So the number 9 was generated 15 times, so I need to subtract 15 if I want odd numbers that are not 9. Okay, so this is what I'm going to do. So 72 minus 15, okay, that's 57. So we're talking about 57 out of 150. Okay, so 57 divided by 150, all right, that's 0.38 or 38%. All right, they wanted the nearest whole percent, so 38%. And there you go. 5 students, Adriana, Ben, Chandra, Diana, and Ernesto. Whoa, I see what you're doing here. Would each like one of the 4 spots at the regional science fair. Their names are placed in a hat, and 4 names are chosen at random to decide who attends the fair. What is the theoretical probability that Chandra will be chosen as one of the science fair participants? So we're going to do target number of outcomes divided by the total number of outcomes. Okay, there are 5 students and 4 spots. The order doesn't matter, all right? We're just talking about groups of people. So we're going to do combinations as opposed to permutations. All right, so this is 5, but we're choosing 4. So this is a 5 choose 4 situation. Okay, that should give us the total number. All right, so 5, and it's the second option for combinations, and then 4. All right, so there's 5 different groups that could be made in this way. All right, so that's the total. Now, how many of those 5 groups involve Chandra being chosen specifically? All right, I could do another combination, but it would be kind of silly. Let's just use our common sense. If we know that Chandra is definitely going to be chosen, okay, then the question is, how many groups can be made that involve Chandra? Well, they're picking 4 people, so only one person is going to be left out. So we could talk about the group where Ben is left out. So that would be Chandra, and then I'm just going to go by the letters. Okay, so we're going to definitely have C. Well, you know what? Why am I starting with B? Let's start with A is left out. So then that leaves B and D and E. So that's one of the ways that Chandra can be chosen. Okay, what else could it be? All right, so A could be left out, or B could be left out, or D could be left out, or E could be left out. All right, so you know it's going to be 4 ways. I mean, I can sit here and list them all out, but you know that if each situation one person's going to be left out, and it's never going to be Chandra, then it's going to be 1, 2, 3, 4 people are going to be left out. So there are 4 ways that Chandra could be in. So 4/5. So that's the theoretical probability. As a decimal, this is 0.8 or 80%. Okay, boom. There you go. Alright, just as a side note, if you wanted to do it as a combination, once you eliminate Chandra from the guessing, because she's automatically in. Once we eliminate Chandra, we have 4 choices left for students, and we are choosing 3. 3 remaining spots. So you could have looked at this as a 4 choose 3 situation once you take Chandra out of it. So if you did that for combination 3, then there's your 4. That's another way you could have gotten the 4. The table shows the results of a survey in which 10th grade students were asked how many siblings, brothers and or sisters, they have. So, number of siblings and the number of students that had that many siblings. Okay, what is the experimental probability that a 10th grade student chosen at random has at least 1, but no more than 2 siblings? All right, at least 1. Okay, so at least 1 would be 1 or more. Okay, so that could be like this many or this many or this many. At least 1. But wait a minute, they said no more than 2. That means I got to forget about that last one I just put down. So we're really just talking about either 1 sibling or 2. At least 1, no more than 2. That's either 1 or 2. So this is our target outcomes, all right, that we just highlighted. So if we want the experimental probability, we're going to use this data, and we're going to do the target number of outcomes divided by the total number of outcomes. All right, target over total. Well, the total number of outcomes is just the total number of students here. All right, if you add all those up, you get 40. Now the target number, we already highlighted that, so that's 28, 18 plus 10. So 28 students with the correct number of siblings, the target number of siblings, divided by the total number of students, which is 40. Okay, so they want this as a percent to the nearest whole number, so we would divide this out. So 28 divided by 40. Okay, that's 0.7. If you move that decimal twice, that's going to be 70%. All right, same thing if you multiply by 100. Okay, so 70%. Boom. There it is. I hope this video was helpful. Good luck on your quiz.